Welcome to this video on AI concepts in Java. After watching this video, you will be able to describe fundamental AI concepts and explain AI implementation in Java. Artificial intelligence, or AI, is transforming the ways we interact with everyday technology. In simple terms, AI enables machines to perform tasks that typically require human intelligence. These tasks include decision-making based on data, recognizing patterns in data, and understanding natural language. AI is powered by several components that enable machines to perform tasks that typically require human intelligence. One essential element of AI is decision-making, which involves making choices based on a set of rules or available data. Another important component is learning from data, also known as machine learning. This process teaches the system to identify patterns in large amounts of information and use those patterns to make predictions or improve its performance over time. Natural language processing, or NLP, enables computers to understand, interpret, and respond to human language, making it possible for us to communicate with machines in more natural and intuitive ways. Lastly, neural networks are designed to mimic the way the human brain processes information. These interconnected systems help AI recognize complex patterns and solve problems in a way that resembles human thinking. Together, these components form the foundation of modern AI technologies. At its core, AI often starts with decision-making. Let's create a simple decision-making system in Java using if-else statements. Suppose you're building an app that suggests activities based on weather. This code snippet demonstrates how to use decision-making with if-else logic. Add an input so the program accepts a weather condition, such as sunny, rainy, or cloudy. Based on the input, the logic chooses an activity using if-else statements. For example, this type of logic is used in fitness apps to recommend outdoor or indoor activities based on weather data. Machine learning is a subset of AI where computers learn patterns from data without being explicitly programmed. For beginners, let's explore linear regression, which predicts outcomes using a straight line. Linear regression is a simple yet powerful concept used to predict values, such as sales or trends, based on historical data. It works by fitting a straight line through a set of data points to model the relationship between an input and an output. The equation for this line is y is equal to mx plus b, where y is the predicted value, x is the input variable, m is the slope of the line, and b is the intercept. The slope m tells us how much y changes for each unit increase in x, showing the rate of change. The intercept, b, represents the value of y when x is 0, which is the starting point of our prediction line. Linear regression helps us make informed guesses about future outcomes by drawing from patterns in past data. Let's look at an example for predicting sales for future months. Imagine you have data on sales for the last 5 months and want to predict sales for the 6th month. You would use code similar to this code snippet. The program starts with training data. The past sales numbers are matched with the months they occurred. Then, it performs calculations to understand the pattern. The slope, or m, shows how much sales typically increase each month, and the intercept, or b, represents the sales starting point of the prediction. With these two pieces, the program uses the equation y equals mx plus by, which equals mx plus b, to make a prediction. In this case, it's used to estimate sales for the 6th month. Based on the data provided, the predicted sales in month 6 will be 600. In a real-world scenario, you could use linear regression to forecast tasks, such as predicting stock prices, demand for products, or website traffic trends. You can also use Java to build a chatbot. Chatbots are interactive programs that simulate human-like conversations. Let's create a simple chatbot that responds to user inputs. You might use this code snippet. First, the chatbot listens for user input using Scanner. Then, it converts the input to lowercase to make matching easier. Next comes pattern matching. The chatbot looks for specific keywords, such as hello, and responds with a predefined response. Finally, there's an exit condition. When the user says bye, the chatbot recognizes the command and ends the conversation. This logic forms the foundation of customer support bots used by companies or banks. Natural language processing, or NLP, allows machines to process human language. A basic NLP task is tokenization, which is breaking text into individual words. This code snippet shows an example of tokenizing text. The string tokenizer splits the text into words, also known as tokens. Each token is then printed one by one. Search engines use this process of tokenization to analyze user queries. AI plays a significant role in program development, enabling systems to make decisions, predict outcomes, and understand human language. By implementing these concepts in Java, you can develop practical applications such as chatbots and data predictions to handle real-world scenarios. In this video, you learned that AI enables machines to mimic human intelligence through tasks such as decision-making, learning from data, and understanding natural language, which are key concepts that form the foundation of AI. You can implement AI in code using if-else statements for decision-making, such as suggesting activities based on weather conditions. Machine learning uses linear regression, which can be coded in Java to predict outcomes such as future sales based on past data trends. Chatbots use pattern matching and keyword detection to simulate conversation and are often used in customer service bots. NLP uses tokenization, where text is broken into words, and is used for analyzing language in applications such as search engines.